Good afternoon. I'm a research software engineer at Newcastle University. I'm not a hydrologist. I don't know an awful lot about the simulators. I'm an engineer, a mechanical engineer and a software developer. So I'm going to talk there's been a few strategic talks. I'm going to talk very much from the point of view of a practitioner and how DAFNI's been invaluable really in this project that I've been working on for the past 9 months. So, as me, I work at Newcastle Data at Newcastle University. This project's called Pyramid, and it's got a fairly impenetrable algorithm. So, platform for dynamic, hyper-resolution, near real-time flood risk assessment, integrating repurposed and novel data sources. So there's quite a bit of creativity in coming up with Pyramid out of that. So this is a collaboration between Newcastle University and the Civil Engineering Group, Department, the Water Research Group, the Urban Observatory at Newcastle, Loughborough Civil Engineering Department, Newcastle Data, which is where I work, and then a bunch of external stakeholders, including the City Council, National Rail, Highways Agency, and also residents and community groups, and the citizen data thing's been mentioned a few times today, so I'll touch on that a little bit. Okay, so this is the problem that this project is attempting to do something about. These are floods in Newcastle in 2012. The top left one's the Cowgate roundabout. It's a very big intersection at the end of the central motorway that submerged. Underpass there's quite near our office. Railway line, I think that's the Newcastle to Carlisle Railway, and some houses up in Walker, I think. So one of the things about surface water flooding is movable objects like cars and bins and things like that are actually form quite a big part of the problem and often aren't included in the simulation. So the research project is attempting to amalgamate a bunch of different data sources. So environmental data, so live rainfall. It's billed as a near real-time simulator. So I've got that thing on the right, produces near real-time flood risk reporting. What does that really mean? Is it a digital twin? Is it supposed to do some kind of forecasting, or is it going to provide some sort of decision-making capability? So that's still an open question, really. I kind of concentrate on building the tool at the minute, and then see where that leads us. So along with the environmental data, which is kind of live data, there's static data, geophysical data, land use, land elevation, satellite imagery, and drone imagery. Entertainingly, the drones quite often don't work when it rains, so we're not quite sure how that's going to be addressed. And then community group and reported data. So there are some groups in the region who have CCTV, or they have their own rain meters. They report blocked rains and that kind of thing. So we'd like to bring this kind of data into the project as well. There are other kind of curious issues around architectural features on streets which have influence over the way that water flows through urban environments that we'd like to capture, but I think that's probably going to be a little bit of further development of this project. So the main middle of the project are these two hydrological simulators. A few people in here probably use or have heard of them. So SheTran, which is a Newcastle University piece of software, and HyPIMS, which is another hydrological simulator at a much finer resolution. And they do different things. They incorporate different aspects of water flow. And the idea is to use SheTran to do broad simulation and produce boundary conditions for HyPIMS. And then there's this another piece of machine learning, which is to identify floating debris and bring these into the simulation. So that's a lot more blurry than it looked on my computer screen, but kind of fundamentally, what I've just summed up there's a bunch of static data. There's a bunch of external dynamic data. So we've got Urban Observatory radar and gauge rainfall data. NGIF rainfall, which is Newcastle Green Infrastructure Facility. And we've got these just the general receptors at the bottom, which is anything to do with mainly kind of special interest groups or other forms of data that can feed into this system. So we're kind of faced with this problem of extracting this data from this static data. Where do we store it? All of this other data comes in through an API. Some quality control there. And then the three sort of heavier boxes are our simulators. So this data has to go into the simulators, has to go into satellite data, has to go into this object detection piece of software. We have the high-level hydrological simulation through Sheetran. That data is then got to go into the finer scale simulator, which is this HiPIMS simulator, and that will integrate the boundary conditions and the floating debris. And then we have to publish it and visualize it, ideally as a kind of decision support tool. So I came on at this project as an RSE. I only worked 2 days a week on this project. There were 4 RAs. It was fairly advanced along the schedule at the time. Limited staff resource. The RAs are interested in research. They're doing simulator development, machine learning. This problem occurs quite regularly, obviously. Everybody will have seen this kind of problem. So we had our co-investigator leave the project. So we're kind of at a point, well, how do we solve this? So we looked at things like Microsoft Azure, building a Kubernetes system on Azure, or building an in-house solution using virtual machines within our IT department. It needed to be pragmatic. Would ideally like to reuse experience and technology where possible. I didn't want to do any more work than I needed to. So that led us to DAFNI, mainly through Craig Robson here and Fergus McLean at Newcastle, who's now in Newcastle Data. So I went through a bit of an exercise of looking at whether DAFNI is right for this project. So so there's no doubt that we could not have done this project without DAFNI. There's no way that I could have built a Kubernetes solution in the time the project's running. It's got another year and a bit to run. So sort of from the research software engineering background, it has some really good features. We can containerize applications, which is what we do all the time. It's got a mature platform. It's this Kubernetes platform with an awful lot of storage and a development roadmap that we can use. It's free for academic use. So we were faced with the prospect of building a virtual machine cluster, which would cost an absolute fortune. It's got pretty good compute facility. 200, I think it's a bit more than 200 nodes, but 10 GPU nodes. Support team are fantastic. I sort of the risk of being a bit over effusive, I can't sing their praises enough. The response on Slack and direct emails and things is absolutely great. So in terms of kind of getting up and running and being able to use the platform's been great. Built on existing expertise within the universities, so we've got Craig here and some other practitioners. We didn't need to build our own framework from scratch. The project groups and the data and model search on DAFNI is really, really good. So we've been able to use some of the models that are already done there. And the GitHub integration and automation has been really, really good as well. So we're just starting to do automatic deployment of our models. So it does have some limitations from us. So this is the kind of pros and cons I drew up when I was working out whether we should use DAFNI. So the APIs, it does have some documentation, but it's not very informative. And all of the work that I'm trying to do is through APIs and command line interfaces, because we're trying to build everything as through data, infrastructure as data. Can't really do job scheduling at the minute, so we'd like to trigger jobs from time intervals with this near real-time simulator. Visualization for us will be an external component, so we'll have to bring that outside of the DAFNI platform and be like a user interface where we can present flood risk to the interested parties. It's a work in progress, so sometimes it's down. Sometimes things just don't work. I've broken it a number of times, and Tom, who's left DAFNI, he helped me an awful lot with that. So there's a lot of manual work, quite often has to be done. The workflow interface is really good to see that that's been improved, because that's been quite limited. And the UI in general, which is why we're kind of trying to do everything through infrastructure as code techniques. Yeah, downtime and outages, so it's not like working on Azure where you've got, you know, pretty much 24/7, 365 support. Yeah, so some features are only available on Quest, like multiple GPUs. Yeah, there's sort of internal and external data. I think that's why I broke it, trying to upload a model that was too big, and it crashed the ingestion process. And it can't execute parallel jobs at the minute, so that sounds like a big load of complaints. It's not. It's like, these are the things we, you know, this is our assessment of DAFNI, but having said all that, as a research institution, it's been absolutely invaluable for us to get this project done. So that's our kind of DAFNI workflow. These are, it's the same workflow as a lot of other projects, obviously. So we've kind of got the same stages that I've heard a couple of times as this read external, which pulls in all the data from APIs, runs through the object detection and SheTran, and then does some data conversion, and then sends that to the HyPIMS model. So we've got three sources of data: the external data, which is coming from these APIs, and then internal data, which is data we've been able to store in DAFNI as datasets, such as land elevation data, and a lot of test data, actually. That's been one of my main focuses, has been able to test these individual models, so I can have data as a data set in DAFNI and bring that in to an individual model like SheTran to be able to make sure it's doing what it's supposed to do. And then the generated data is obviously just the data that gets generated from the models. So a couple of things so this is what will fit in DAFNI for us, and then we will take we'll take some of the visualization outside through a web API. And then this triggering thing, I think will probably work with, unless other people have done this, they've got other suggestions, we'll probably work with Microsoft Azure, some kind of functions in there to be able to trigger regularly the runs of the workflow. So one of the things that we haven't looked at yet is the new loops feature, and I think a couple of the models will probably incorporate that, because they can do a hot start on data they've already got with some parameter changes. But I haven't been able to have a look at that yet. Okay, so what have we actually completed? Where are we now? So this is pretty much where we're up to. So HyPIMS is implemented, tested on DAFNI. That does work. The conversion between SheTran and DAFNI is in progress. SheTran's an existing model, so I was able to take that from a model that had already been uploaded, I think, by Fergus. There's some new developments going to go into that, but it's great to have something that's already there. This has gone a bit formatting's a bit odd with this, but the object detection, which is a machine learning thing, that has been tested, but not on DAFNI yet, mainly because I can't upload it because it's too big. So that's something I need to work with the team on. And we've got a version 0.1 of the API tested, and that works. So some of the data is there. The interface has been designed. Don't know what we're doing about triggering yet. As I say, I think that'll be an Azure thing. And what happens between the result of a workflow run in DAFNI and how it gets onto an external visualization is to be designed. So that's where we are with this project at the minute. I work on it consistently 2 days a week, so I'm an active developer on our project. So just a few challenges. Yeah, so I've mentioned these GPU models are very complex and they're very large. Even the Docker image creation is really complicated. So I know that's not part of DAFNI, but if you're going to use DAFNI, you have to create Docker images. A lot of our researchers don't really know how to build Docker images, so there's a kind of a bit of a skills gap there, and that's taken a lot of time. As I say, the ingestion got broken by the HyPIMS model, and I haven't even attempted the other one because it's double the size. So there's that's something I've been working with the development team on. Yeah, I mentioned the job triggering, and yeah, there's the image creation DAFNI asset version management is still quite confusing for non-specialists. So the team who don't use this all the time, they sort of do for a bit and then they forget, and then you kind of got to remind them of how it works. So one of the few things we're trying to do at the minute is instead of using the API to construct the workflow, we've got a JSON description of the workflow, which we can use the API to automatically build a workflow. So we have an infrastructure as code solution there, which is much better for us. It changes a lot, does the workflow structure, and I can maintain that in a repository and update that and just rebuild it. We haven't looked at the DAFNI version 3.1 features yet, but I think they'll be useful. We haven't really looked at how we can leverage the 10 GPUs yet. It's only our GPU models are only running on one GPU, so we'd like to change that. One of the things that I think is quite difficult with DAFNI is it often doesn't tell you what's gone wrong when it goes wrong. So one of the things I'm looking at is, as a team, we use Sentry, Sentry.io, which is an error collection facility. So you can, all the works in Python, all of our scripts are Python based, but Sentry works with other languages. So it can report errors and exceptions and things directly to this web platform. So even though some of the DAFNI error reporting is a bit opaque, I can report it to an external platform, which is pretty handy, and it does work. So that's our conclusion. DAFNI is providing the backbone of our pyramid demonstrator system. So this is a demonstrator. It's it's not going to be a working thing that we're going to give to the council and have them use. It'll be something we'll get feedback on for container management, workflow orchestration, and the storage of the static data, external data from APIs, and we'll use this Azure services. And that's it. Hopefully that was of some use. And I know I've talked to a couple of people who may be starting the journey on DAFNI. So if you want to speak to me and discuss any of the things that I've come across, then just get in touch. Thank you very much.
Okay, thanks very much, Robin.